Hi, everybody. This is Joanne Manister. Welcome to Read Science, where we like to talk to science book authors, popular science book authors, about how they take complex topics and make them entertaining and engaging and comprehensible to the general public. And today we have with us author Lee Billings, who is debuting with his first book, 5 Billion Years of Solitude, The Search for Life Among the Stars. And Lee, I had your bio up here so nicely. So he writes about the intersections of science, technology, and culture for Nature, Nautilus, New Scientist, Popular Mechanics, Scientific American, and many other publications. We are seeing this as a trend. People who write books tend to write for lots of great publications. So anyway, so you spend time in this book talking about the quest to search for life on other planets, or at least find planets that might hold life. Mm-hmm. So we'll let Jeff start with the first question.
I get the first question. It's a longish question, but I get to start because it's a sort of biographical topic once I get around to it. And what it's about is your introduction to the book, which I thought was really fascinating, unusual, but worked pretty well because it was so personal when you got down to it. One fact that I took away from the introduction is that I can remember what year you were born in because it was a year before I was finished my PhD, which makes me feel a little bit older now, but that's okay. We can deal with that. But you told some very nice story where you trace your interest in science journalism and this particular topic of exoplanets, the search for extraterrestrial life, to the occasion when you were 4 years old and saw Halley's Comet. And then later on to more youthful experiences with your backyard telescope. My disclosure is I had a backyard telescope, and now I'm seeing, as I read the book, you've talked to a number of people who are involved in this search. They're all interesting, and they almost all had backyard telescopes in their youth.
Yeah.
I want you to tell me some about your youth. Let's hear that story again, if you would. But then the real question is, is there a pattern? Do all of these people have backyard telescopes? Did we all have formative times when we said, science?
Yeah, I mean, I kind of think so. And you know, I will say that maybe what separates the men from the boys, or maybe a better way to put it is, the scientists from the science journalists is, or maybe the astronomers from the scientists is whether or not you make your own telescope. Because, you hear these stories of kind of the greats in astronomy, and so often it's like they actually grind their own mirrors and lenses and things, and they put it in like, a toilet paper tube, and they're like Galileo. So I wasn't like that at all. I think mine was from, I think it was from Sears, or maybe from like Office Depot or something, and it didn't really work very well. But
mine was from Sears, yeah. And I didn't grind my own optics.
Yeah, so that's why we're not astronomers, right? So I guess if we were destined for astronomy, we would have done that. But yeah, and I have to say, this is an exclusive little tidbit for y'all. When I ran this story by my parents, they don't really remember it very well. I remember it vividly. So I'm not quite sure what happened. I mean, I don't think this is a constructed memory on my part. I think it's real. I think it did happen. I was only 4, of course, but I remember it quite vividly. But they remember bonfires, and they remember Halley's Comet, but they don't remember kind of one thing happening all at once. So I don't know what happened there. But the way I remember
it was your formative experience, not their formative experience. For them, it was just a number of interesting things that you did.
Right.
I think it makes a big emotional difference, I think.
I mean, at the time, it was just one of these things where, you see this little wispy object in the sky, you haven't seen it there before, you ask your parents what it is, you ask someone what it is, they explain it's a comet, and you're kind of thinking, what does that mean? And at the time, I remember watching the film adaptation of The Little Prince, this, beautiful book from Saint-Exupéry, and yeah, in the book, the little boy, the little prince, kind of starts out on an asteroid or a comet, and then he's traveling through the solar system. So I didn't, I was so young, I didn't really realize what space was really like back then, and I just, I thought, maybe could I be like the little prince? Could I go around all these other little worlds and meet interesting things and people, have amazing experiences? So when I saw that this little wisp in the sky was a comet, I had the sense that it was another place, that it was someplace, maybe you could stand on the surface and you'd look out and you'd see something very different than you would here on Earth. And I mean, that was kind of a powerful moment. I wouldn't say that was actually the the most key thing that happened to me in terms of being interested in the sky, but I mean, it was a very powerful memory. And in particular, when you find out little details like, wow, Halley's Comet is going to come back a very long time from now, and you're going to be an old man when it comes back. And as a little boy, to hear that and realize that, I mean, you don't really have a full sense of your own mortality, but you kind of realize how small you are in this much bigger space. So that was kind of a powerful thing.
Do you have
Isn't that what I was going to say? Isn't that what is the plea for continuing, to push for dark skies, to reduce some lighting, so that we feel connected to the sky and feel much smaller? I mean, there's something that's so powerful and humbling. And actually, you have a few scientists in here who say that about how humbling it is, and what a different kind of person it makes you by realizing you're just one tiny little thing in this grand universe. And the more they study it, the humbler they become.
Yeah. It's I mean, I would just say that I live in New York City now, and it kind of breaks my heart every time that I go outside and it's dark, but there's still this huge sky glow. There's still just so many photons being pumped into the sky from downtown Manhattan right down here, and even the street lights around my neighborhood. And you can see maybe a dozen stars, I feel like, and it's just it's so different from when I was a boy and I was living in Alabama and South Carolina. And of course, you could just look up and see these huge vistas and see the Milky Way. I mean, I haven't seen the Milky Way in quite a while, so you feel that loss a little bit. But what's scary is that so many people don't even know that it's missing, right? So many people just grow up in these big metropolitan areas with terribly polluted skies, and they never think, like, gosh, what am I missing? They never actually realize that they're not seeing all this stuff.
So will this have implications for these researchers? I mean, if we don't even care that it's missing, why would we care that we're searching way beyond our solar system for,
well, of course. One thing to think about is that, and one thing that's interesting, I think, about this search, there's been two trends in astronomy, or I shouldn't break it down and make it that quite, bicameral and just say there's been two trends, but there's been this trend, I think, through most of the 20th century, and before that, you think about things like Edwin Hubble's discovery of the expanding universe. You think about the discovery of the cosmic microwave background, the evidence of the Big Bang, and these sorts of things, and the discovery of dark energy in the late 1990s. You have really what's amounted to this incredible stream of discovery, but almost all of it is about, I mean, sure, it's about us right here. It's about our place in the universe, but it's about things that are at the very edge of the universe at the beginning of time. They're so far away, they're distant and dead and ancient, and that's kind of what cosmology has been about in this, in the past century or so. What's interesting, and the connection to the stars you see in the night sky, what's interesting about this search for life, for habitable exoplanets, is it's not about, the edge of space, the beginning of time. It's about the stars that are right next door. There's my puppy about to come in. Everyone who's listening, this is my puppy being brought back for a walk.
Hey.
She's going to be a little loud. Hey there.
She can come on camera.
Yeah, there we go. Okay. Back to it. Back to it.
A little puppy appearance.
Hey, come on. Okay, here we go. Okay, she's good. So, where were we? So the difference between kind of that old way of looking at things in the past century of cosmology-focused investigation, I think, and what's going on now is that, again, it's not dealing with these things that are very far away and very removed from us. It's dealing with the stars that we can see in the sky most of the time. It's dealing with things that are right immediately around us. It's dealing with places that are potentially just like here, like Earth. And I think that that's an extraordinarily compelling development that is new in astronomy. I mean, of course, we've been looking at signs of life or looking for signs of life on planets in our solar system, planetary science, for quite a while. We haven't really found a lot of stuff. Mars looks pretty dead. Venus looks pretty dead. Europa, Titan, those places look pretty cool. Enceladus, but we don't really know a lot about them yet because they're pretty far away. So it is kind of this new opportunity. I feel like it's something that hasn't really existed in astronomy before, as most people, conceive of it. So there is a connection that can be forged between the stars that you see in the night sky, the closest stars to our solar system, and this quest for other life, because we're never going to probably find signs of life, at least the way that we're talking about right now, in another galaxy or on the other side of the universe. I mean, maybe we will, but that's, I think, much more difficult.
There's a common question here that I like to ask many of our authors. With so much going on, so many new discoveries, this burst of activity with exoplanet research and discoveries lately that have just seemed to be pouring out, and not really to make a deal out of it and actually try to divide it up by fractions or anything, but just as a rhetorical point, like how much of that comes from the fact that we can now see things differently. We have new techniques that are a little bit more advanced, a little more precise. And how much of that is new ideas, and where the zeitgeist for what astronomers are thinking about and where the concepts that have developed have gotten to, that finally led us to say, we can search for other planets because we can use these tools to see the luminosity, the apparent luminosity change if a planet passes, or we can just start to detect the gravitational effects of large planets, and then soon we probably will be able to do spectroscopy on their atmospheres to see if we had one recently where we say, we think we've detected an actual atmosphere visually, and it's like, well, that's an exciting advance. So the technology allows us to do things, but we have to have the ideas that say we can use this technology, and it seems like there have been a lot of ideas going on very recently too.
Yeah, it's a mixture of both. Interestingly enough, so you kind of referenced, and just to break it down a little bit more for listeners, viewers, I should say, the way that people typically find planets now, they do it through what's called the wobble method, which is where they're looking for indirect tugs of a circling planet upon its star, in the same way that the moon raises the tides on Earth. The planet essentially is slightly shifting its host star in its orbit, and you can detect that wobble. So that's one way that we look at things. Another way to find them is through transits, which you mentioned, or the dimming of a star, and that's basically when a planet crosses the face of its star as seen from Earth and casts a shadow towards our solar system, which we can then detect as a slight dimming in the star's brightness. So these are kind of indirect methods. They actually go back. There's a really great paper, a prescient paper by this guy named Otto Struve, who was kind of a key astronomer, Russian-American astronomer back in the before the 1950s, but in the 1950s is when he wrote this paper. And I think it's called A Proposal for High Precision Radio Velocity. I can't quite remember the name of the paper, but anyway, it was published, I think, in like 1951 or 1952 or 55. And in that paper, it's a little thing. It's like 2 pages. He actually lays out both of those methods. He says, if you want to find planets, you can do it this way through wobbles or this way through transits. So he was very prescient. And then, of course, it took another 40 years for the field to catch up with him. One interesting thing when you talk about the difference between technology and ideas is that the capabilities to find the first planets that were found around sun-like stars, the hot Jupiters, these ginormous planets that are super close, just hugging their stars' faces, and consequently they have a really big wobble that they induce on the star of like hundreds of meters per second. The technology to detect those was actually available probably in the 70s, certainly in the 80s. And the first real detected planet probably traces back to about 1988, 1989, and most people just didn't recognize it at the time. They didn't think it was real. Since then, it has been proved real. But the point is that we actually had the capabilities before we had the idea, because no one thought that these strange, bizarre planetary configurations, these planets hugging their stars, supermassive planets hugging their stars, could actually exist, and so no one looked for them. Right. And of course, maybe we're kind of blinkered like that now too in our search for life. We're just focused on Earth-like planets, planets with liquid water and rocky surfaces and thin atmospheres. So maybe we really don't. Well, we clearly don't know a lot, but we have to start from what we know. So that's an important thing to think about.
Well, these are really important stories to tell. I'm about to pass it back to Joanne, because the science communication aspect is, this is the way science works, and it's this interplay of you can't use the technology until you have the idea. Sometimes the idea says we have to push the technology, and they go back and forth. It doesn't just like Galileo doesn't wake up and say, I need to invent a telescope because then I can look and see whether there are small planets circling other planets. It does not happen that way. It goes back and forth, and that, well, there are important things to understand from that too, like what seems to many people like the peculiar surprise that two people could discover the same thing at virtually the same time after thousands of years of not having discovered the same thing. The process of science is a lot more interesting than is usually presented. Okay, Joanne.
Well, so I guess there's a couple questions I want to ask, and one is actually a comment. For some reason, I found myself really drawn into the chapter about telescopes, like the ones that we're trying to get built, and then we lose funding for, and then the different ways we we can set up a telescope because there are limits, right?
Yeah.
These telescopes, they have optical limits and size limits. Do they need to be cryogenically cooled, and then ultimately funding limits. And you brought up a couple things. One is this how space exploration is not just about science. Like of so many fields of science, it is also geopolitical. I mean, it is extremely geopolitical. And so I'd like you to expand on that, but then also what you see your role in communicating, in how to bring us, the general public up to speed, and maybe even, people who are making these geopolitical decisions on what gets funding and what doesn't, and all that. So that, I don't know, that chapter just, I loved it. It was, I think, my favorite chapter.
Thank you. That's actually one of the most important chapters of the book, because that is the chapter that's trying to make an argument. And actually, there's an excerpt on Pop Sci today that's taking some of that chapter. But it's a chapter that's trying to make the argument that this is something we can do. We can go out there if we put our minds to it. If we get enough public support behind it, this is something we can do, and we can do it relatively soon. And yet, of course, it seems like we're not doing that. It seems like we're going to have to wait 30 or 40 years or maybe more. I don't want to be on my deathbed and 85 years old or 95 years old when these things are starting to happen. I want this to happen now because it can. And maybe that's selfish. Actually, it definitely is selfish. So I'm comfortable saying that. So, but yeah, there's a quote from a guy in the book, actually, Wes Traub. He's the head, the director. Actually, I don't know if the director is the right title, but he's the head of NASA's exoplanet exploration programs. And I got to interview him a couple of different times and interact with him. And one thing that he says in relation to these big, ambitious telescopes and how they may or may not be built is, when a project, when an experiment, when the science, gets to be, or actually, no, maybe he didn't say this. He did say this, but I think someone else in the book is, I quote, saying it, because a lot of these people kind of say the same things because they're all moving in the same group. But the notion is that when an experiment gets to be on the order of $1 billion, it's no longer just about the science. It's in fact, the science kind of takes a back seat, and it becomes about again, geopolitics and pork barrel spending and pleasing constituents and all that stuff. And in the model of big federally funded science, to some degree, that's sort of how it should be. Maybe not the pork barrel part, but the notion that you are using public money to do these things, and you're using quite a lot of it. And therefore, I think you should be receptive and respectful of what the public actually says you should do with it. And that's kind of a, that's something that I think is difficult to grapple with for a lot of scientists whose work is mostly dependent upon these sorts of very large, big-ticket items. Because naturally, a lot of times the public doesn't really know what's the most compelling scientific question, or what the most important thing is. And if you kowtow to the public viewpoint too much, you can end up spinning your wheels and going nowhere, and not doing the really interesting science you wanted to do, not hitting the marks, not getting the discoveries you want. So it's risky, but at the same time, you do need to balance it with the fact that there is kind of a PR element here that's very important and relevant. And so two things I would say is that maybe that's not the only model for doing big science. I kind of explore that at the end of the book, where in that chapter and then the next chapter, how perhaps there are other avenues to making these big ambitious things happen that don't require being just tied at the hip to something like NASA. I don't really know if that's true, but I think it's important to think about these ideas, these alternate avenues, just in particular in our our kind of current age of austerity, as everyone likes to call it. In these economic times of diminishing budgets, static budgets at best, you need to think about other ways to get big important things done that don't require $10 billion of government money and 2 generations.
Right.
So, and the only thing I would say finally is that you asked about what I think my role is, and I think that my role obviously is in. I really don't want to call myself an activist. I don't think I'm like that. I will say I'm an advocate. I do have personal feelings and desires when it comes to these big questions and things that I would like to see answered in my lifetime. So I'm not going to try to have this view from nowhere and pretend that I'm just somehow totally objective and that my opinion doesn't matter. But I do think that my real role is to kind of get out of the way to some degree and let these people tell their stories, let the scientists talk in their own words, present their views and their ideas, and I'm kind of more of a catalyst where I'll just kind of prod them or I'll try to convert some of what they say, if it's difficult and abstruse, into something that's a little more palatable. And by doing that, I like to think that I can get more people excited about this idea and about this quest, the notion that we can go out and we can find life around other stars very soon if we want.
It can be difficult and irritating to engage the public, but it can also be very fruitful, and it needs to be done. And I think you're probably right that there could be other business models, if you will, for how to do big science, and we know we need to do big science, and they don't exist right now, these paths to doing big science, but they're not going to exist if we don't imagine them now and try to make them happen either.
Right.
And you have to do that. And when I, it's now 20 years, but I did a physics experiment on the space shuttle. And it was not big. It was not big science because it was only, now we say only, $2.5 million. Fine. But then, the question, and I can't see other people not asking themselves, like, are we really doing $2.5 million worth of science?
Right.
With this experiment? And I think, sometimes we try to justify it because you don't want to say embarrassing things on camera and things. But I think the answer really was no. But I felt like we were doing $2.5 million worth of something, because it felt, in addition to trying to get the science done and make good science, we had to make the experiment work. We had to learn methods for getting onto the space shuttle and launching at the right time. We had to learn ways to bring teams of people together to get fancy science instruments to work that were very delicate, that wouldn't otherwise. All sorts of things. And it seemed, I don't think it's immodest to say, it seemed very pioneering. And I think the pioneering and the adventure is something we have to do because we know we want to do these things. We have to find out how to do them. And if we don't do that, then we can't use space routinely without doing the pioneering work, or we can't build these business models without failing at some things to find the way to do it. So, how do you feel like SETI, the early days of SETI? I'm not sure anyone really expected anything to happen, but if you don't start out down that path, you're not going to get anywhere, right? So
right. As my old basketball coach used to say, you miss 100% of the shots you don't take, right? So, I actually, so real quick, what was your experiment on the space shuttle? Just
It was a thermodynamics experiment. We were measuring the lifetimes of fluctuations in critical fluids, which we wanted to do in microgravity. So strictly speaking, we were a microgravity experiment. We were one of the very few experiments where the effect we were trying to look at was so spoiled by being on Earth's gravity. As you got to the interesting bits, gravity would say, no, don't look here.
Right.
And if we could turn the gravity down, we could get in 100 times closer in temperature to this thermodynamic critical point, and we could see these fluctuations grow, measure their properties, and that was thought through calculations from the renormalization group theory, which was, all that complicated stuff, was thought to be the critical thing to measure, and so
our
contribution at the time.
I mean, and that stuff is important. It's basic fundamental research. The problem, as you mentioned, I mean, $2.5 million sounds like a steal kind of right now when you think about space science, but
these days.
yeah, these days. But of course, the reason why it's so expensive, I mean, that is a lot of money, and the reason why it's so expensive is because access to space is so expensive. So, there's a really there's a network of problems here. The geopolitical angle of space science and exploration is that these are very difficult things to do. They typically require nation states to do them, and the way that they do it, most of the time failure is not an option, right? Especially when you're involving humans. So everything has to be triply redundant or quadruply redundant, and tested out the wazoo, and you can't fail. You can't fail because there's too much riding on it, because it's just too dang expensive. And so the model.
There's no affordable way to do it over, and the other part that makes it really expensive is that there's always going to be a human around, and so we had a lot of human safety things to go through that had nothing to do, because our experiment was in the shuttle bay and ran by itself, but they had to operate the mission, and I think human exploration is important too. I think that's part of the adventure, and I think adventure is downplayed. Pioneering adventure is downplayed as an important, it doesn't feed people or make money for people really, so it's not to be essential, but I think it's essential. There's so many intangibles involved that it feels to me like you have to do, but we always had the joke that said, if you just wanted to fly a paperclip on the space shuttle, it would cost $1.5 million.
Yeah.
By the time you went through the paperwork and the reviews and all of those things.
Yeah.
So I'd like to turn back sort of to the book and your role. And so I had expressed to you during our tests of the Hangout, Lee, that I had read Richard Panik, who has been a guest on here with Temple Grandin. I read his book, The 4% Universe. And I felt like, first of all, there are parallels in the way you guys are telling this story, because you chose to tell your respective stories through the people who are doing these stories. Because, of course, you could say, yes, we take this and we look, astronomers do this, and you sort of kept it a little impersonal, but you instead chose to talk about, someone sitting at breakfast, they're having coffee, this idea comes to them, their struggles as a graduate student and things like that. So that really adds an element to a story that not everybody's going to do when they write a book. So I guess what made you decide that this was the way you needed to go for this?
Well, one of the reasons why I got into science writing in the first place, or science journalism versus other kinds of journalism, is because I guess I get really uncomfortable with a lot of standoffish, high tension conflict. I didn't like the source journalist relationship, where I was like a kind of a terrible parasitic leech, or that was trying to infect them with a horrible disease and ruin their reputation or their life, and that's so often, I think, the kind of relationship that you see in this more adversarial relationship in other aspects of journalism, whether it's occasionally sports journalism, political journalism, a lot of business journalism, and it doesn't mean that I just want to get super duper buddy with all my sources. It just means that I don't want to always be. By the way, what is the rating on this? Can I say, do you bleep things out, or can I just say I don't want to be an asshole? Can I say that?
Yeah, say it.
Okay.
Say it. I don't expect the middle schoolers are watching. I think they're in class somewhere.
I think we've said worse. Yes, we had our program about shit before, so it's
okay. Good to know. So I mean, one thing that drew me to science journalism was that most of the time scientists, they really do want to talk to you. They really do want to speak to you about their work. They want to give you the time of day, and more than just the time of day. And so a lot of times when I was talking to these researchers while I was researching the book and doing articles in support of that, I just found that they were so open and sharing with their time. I started to get to know them more as people instead of just as these lofty ivory tower figureheads. And I wanted to kind of capture that and bring that to readers. Not only just because that was what I experienced, I want to write what I know, but also because I feel like in these sorts of questions, these questions about what are we, where do we come from, where are we going, the questions that astrobiology and the search for extraterrestrial life deals with, it's something that everyone can connect with. So when you have these kinds of I guess, these great figures of science, these great men and women of science, and you can get inside their head and you can see how they're people too and how they have these same doubts and these same conflicts and troubles as everyone else. I think it kind of demystifies science in a way, and it dismantles some of that, great demigod of science BS narrative. I think that happens too often in a lot of science journalism, where it's just this kind of boosterism, this naive promotion that is just not at all jiving with reality.
I don't care. I actively discare for the cult of scientist as genius and those sorts of things. But showing a real living process for how science works is, I think, one of the small handful of things that Joanne and I agree are fundamentally important. And science as a human endeavor done by actual real people, sensationalism aside, or personal drama aside, is an important thing to show. These are real people. They have thoughts. They have flaws, and sometimes they get things wrong, and sometimes they get into fights. And if you can sort of avoid the drama, but use that as a POV for relating that, that shows a reality that I think is useful to portray. And don't you think? I don't know whether it's just been the zeitgeist, but there's a lot more people who are in your place and have been doing science journalism and writing good stories, and seem more open now to taking the point of view of the scientists doing the work in order to show some of that, rather than to show them as celebrities or something.
Well, it's a little bit of both. I mean, there is kind of I'm not gonna lie and say there's no adulation, right? I mean, I definitely.
Well, no. Of course not.
Yeah, I do look at some of these people and I think, gosh, they are a lot smarter than me. Oh my gosh, and that,
you have a seminar run by a Nobel Prize winner, a lot more physicists are going to go to that one than to the graduate student, with the good story.
Right. But yeah, it's true that portraying the kind of the more human side of it, I think, is really important, and it's a powerful storytelling device. Maybe it works better for some topics than others. I don't know if talking about the deep personal struggles of I don't know, a material scientist trying to make a new anti-reflective coating is going to be quite the same as someone who's looking for little green men or something. But it's a fruitful technique for sure.
It depends on the person telling the story, and I can think of one book by someone we'll talk about too someday, Joanne. He was a guy who wanted to do something. He was not even an engineer, but he designed a scale, a bathroom scale. And you say, okay, that's not really best for personal thing, but he did it as a memoir, and it's one of the best books I've read, and it illuminates a lot about the engineering process at the same time. It's really an amazing story.
So I got lost. There are so many people in this book, so many people, that I started to lose track of names. A few stood out to me, but I'd like to know, I'm going to put you on the spot.
Oh, no.
Top 3 personalities that people should leave this book going, I'm glad I got to meet that person.
Oh, okay. Well. Oh my gosh. So I'll go ahead and say that one of the biggest ones is Greg Laughlin. I kind of feel bad that I mention his name in almost every single interview I do about the book, and I worry. I feel like he's probably got like a Google alert set up for his name or something, and then so I'm just pinging. I'm throwing all this content at his inbox all the time because I keep mentioning his name. But he was actually kind of my doorway into this subject, and I talk about it a little bit in the introduction. He's a major figure in I think 2 or 3 chapters. And he's a University of California, Santa Cruz astrophysicist who specializes in kind of analyzing a lot of the data that the actual observers, the actual planet hunters looking through telescopes, deliver. And so he's looking at these data sets, trying to find out, what's planets and what's just noise. That's not all he does. He's kind of this really interesting Renaissance man. And I just, every single time I talk to Greg, I learn something new, and I kind of have, my expectations and my view of some topic or another just kind of shifted. And that's remarkable, considering that I've known him, I guess, I've known him for about 6 years, and I've talked to him a lot. And every single time we talk, it's like that. I'm just like, it's a bottomless well of just endless insights. So he's one for sure. And I'm kind of surprised that in a lot of coverage of the book, a lot of critical coverage of the book, for whatever reason, the reviews don't seem to mention his name or his story. Maybe that's a failure on my part, but anyway, he's one for sure. And he's someone to watch and pay a lot of attention to. And another person would be Sarah Seeger.
She was one of my favorites.
She's just, and Sarah's a brilliant, remarkable person and scientist. She's a full professor at MIT. She's kind of both in the astrophysics and planetary science world. She's doing a lot of really interesting work, and just besides just being really brilliant, she's also she's really driven. She's got a pretty unique personality, and I think one reason why she stood out for me was because she gave me a lot more access than most other sources, and that's very clearly reflected in the book, in the stories that are told.
Maybe that's why I liked her, because I felt like I got to know her.
Yeah.
I got to know what she's doing, and the importance of everything. Yes.
Yeah, and so she opened the door for me to kind of find out more about her in that way, and shared a lot with me, and I'm very grateful for that, and I tried to do my best telling her story in the book. And one thing that I kind of left out and I didn't really talk about a whole lot was just this struggle that she represents in a way. I mean, there's a lot of different struggles that she represents, but one that is not in the book actually is how you're supposed to be a top-flight, grade A, world-class researcher while also being able to do something like raise 2 kids on your own. And how can you also be a really great scientist and a really great parent, a really great mother at the same time? And we talked a lot about that, and in earlier drafts, a lot of that material was in. It ended up being cut out. But I'm very pleased to see that she just won, this MacArthur Genius Grant. Yeah. And so I think it's like $625,000, and a big part of what she's doing with that money is actually getting childcare and stuff like that for her 2 adorable, great young boys, Max and Alex. Max and Alex, is that? Hold on. Are those their names? Oh, Sarah, if you're watching, okay. I think that's okay. But so that's another one. And then the third one, I think, Frank Drake, the founder of SETI, is obvious. But I'm actually not going to say that because he's so obvious. I'm going to try to go with someone who's a little more underexposed, and that's Jim Casting. Jim Casting at Penn State University is. I mean, I have trouble kind of encapsulating just how important I think. His work is. I mean, if you think about it, here's this guy. He's a former NASA scientist. He's, again, now at Penn State. He's a geoscientist. He's an atmospheric chemist. And it's not like he single-handedly has done what I'm about to say, but he has kind of been the driving force. I think the way that I've heard other people say it is, over the past 20, 25 years, Jim Casting has done more than any other human on this earth to keep atmospheric chemistry alive and up to date. I mean, in the big scheme of things, maybe not talking about solely IPCC reports and climate change on Earth. He's this brilliant guy, and what he's done essentially is he's figured out things like the rough kind of lower limits of habitability on planets, as far as we know, based upon how much sunlight they get from their stars. He's extended that not only from our own Earth here in our solar system to other planets and other stars. He's also done things like crucial work to help pin down how planetary climate can remain stable and habitable over geological timescales of billions of years. I mean, that's a pretty huge thing to think about, a pretty big question, and the fact that he's been able to reduce it to these equations that really beautifully reflect what we see around us and what we think we see around other stars is just amazing. And one other thing, when you're thinking about the limits of habitability, the long-term evolution of planetary climate, when you put those together, what you get is a rough forecast for how much longer life can exist on Earth. And looking at Casting and his colleagues, their findings on that, you get this answer where it looks like we may have as little as 500 million years left. It may be more like a billion years. And when I say we, I'm talking about complex life, things that can have a conversation and build computers and things like that, not little single-celled organisms. But I just think it's remarkable that this one man, this one largely overlooked man, has done all this great work, and it's just of such utmost importance to every living creature on this planet, when you think about it, about what he's talking about and what he's trying to define, and people just don't know who he is most of the time.
I happen to be in, is just an aside, I happen to be in that chapter right now, and I thought it was pretty clear that you're describing work that is ideas that are foundational and lead things in a particular direction in a really important way.
Yeah, I like that chapter too. I would say Telescope 1, that was the second. And I just really appreciated some little insights, like of course, we're looking at planets light years away, right? So what their spectra comes back at us may not really represent what it is when we get there, if we ever get there, right? Because of this time issue. And I just felt like it was really illuminating. And indeed, I think the people that became my favorites seem to be your favorites, and that, there must be a little bias that comes through in the writing. So it's interesting you mentioned these people, because I was like, they were people I left the chapter going, I remember their names, and I remember what they do. But you had lots of people, and you had people, starting as grad students and things like that. So it was really good. And like I said, I did compare it to the same style that Richard Panik did for 4% Universe, 4% Universe. For some reason, that got my brain. And it was funny then, because in the Telescope chapter, you were talking about how, astronomers and astrophysicists and cosmologists were, it's like some are getting upset. Wait, why are they going to get all that money for that telescope? And what about us? As if that affects individual funding. But, there must just be this sort of fighting for funding, like everywhere.
Yeah, that's definitely something that's contentious, and I in some ways I kind of hope that if the book really takes off and more people start reading it, that maybe that will be highlighted more, or more people will become aware of it. That I've tried to kind of capture some of this contention within the astrophysical, cosmological community, because I think it is really important for kind of the future of space science, of federally funded space science. We have to get better at planning these big missions and executing them in a way that is sustainable. And I mean, ideally, of course, you want to please everybody. You want everyone to be able to do their science with a limited pot of money, even though it's a very large pot of money. It's still limited. You want everyone to be able to do their science, but we do need to be able to make hard choices. And we need to also be cognizant of, again, kind of the public role in this, the way that you are spending federal funds, you're spending taxpayer money. You need to have some connection, I think, to the public and what the public wants you to do. And so the argument that I've made and that I'm making now, that I try to kind of discuss a little bit in the book, is that above and beyond these kind of territorial conflicts and this internecine infighting, I think the community, the astronomy community in the U.S. that's funded by agencies like the NSF or particularly NASA, just really needs to realize that it does need to engage with the public, and it needs to, it needs to also be, I think, somewhat respectful. I mean, I just think that if you're going to try to go out and find gravitational waves with something like LISA up in space, or if you're going to find, if you're going to try to look for, refining the cosmological constant and figure out what dark energy is, if you want to study supermassive black holes and active nuclei and galaxies and things, all that stuff's important, and I think it's all good. But you have to make the case to the taxpayer. You have to make the case to John Q. Public about why it's important and why we should spend billions of dollars doing this, especially if the choice is between doing that kind of stuff and going out and finding biosignatures on another nearby planet orbiting another star. I think that's so super compelling to say that we're not going to do it for 30 years or 40 years when we have the technology, when we know how to do it. To me, I can't fathom it, and I think it's kind of a losing proposition. So, yeah.
Joanna alluded to something about when we finally get to a planet that's light years away, will things be like they are now? And almost certainly the answer is no. But that reminds me that there is a huge topic in here that I wanted to talk about for a little while. Sorry if I short circuit things, but I wanted to talk for a while about deep time, because it's in here, and it is such it seems to me like the incomprehensible topic to try to get to share with non-scientists, because even scientists have trouble holding on to the immense size, as it has turned out in the past century, the immense size of the universe and the immense age of the universe, and how in the world do you go about doing that? And maybe we'll get around to a few inadequate metaphors that I don't much care for either, but deep time is huge, and so much can happen in a universe that is so large and so old. How do you grapple with some topic like that? It's always there.
Yeah, it was a voyage of discovery for me personally, and when I was working on the chapters that really discussed deep time a lot, like I got depressed, frankly, but it was kind of one of these bittersweet melancholies where, on one hand I would feel like, oh my gosh, the Earth is 4.5 billion years old, and you can just wipe out all of human history. It is nothing. It is absolutely nothing in the big scheme of this thing when you think about it, just the size of the time and how long we've been in there, been around, and you'd get depressed about it. But then on the other hand, you think, well, in that whole vast amount of time, that 4.5 billion years, there's been, as far as we can tell, nothing like us. There's been nothing that has all these kind of almost near godlike powers when you think about it in terms of what a biosphere can do. That's really humbling and awe-inspiring and aspirational in a way. So, you can kind of be like, oh, like, we're all going to die, and we mean nothing, and we're just specks of dust in the wind. But then on the other hand, you can be like, hold on now, pump the brakes. We are more powerful, as far as we can tell, than almost anything in the planet's history. I mean, I guess there's a cyanobacteria that oxygenated the Earth's atmosphere billions of years ago, but, they couldn't build interplanetary rockets and radio telescopes and nuclear bombs. I mean, we're pretty cool. We're pretty special, I think, in the biosphere at least. And yeah, so that was something that I had to kind of grapple with in the deep time sections. And I agree with you, though, that fundamentally, when you start realizing just how long these periods of time are and how small we are in comparison to them, I mean, words kind of escape you, and you really can't encapsulate it. You can like write a pretty sentence about it, and it'll feel good, and people reading be like, oh yeah, but we can't get it. We can't grasp that time. Yeah.
But you did say something that I found a little unusual, and this is in the chapter that I'm reading now about Kessling.
Yeah, casting.
Casting.
Thank you. And you observed about him at some point, and I thought it was a surprising way to do it. You described him as having a particular serenity, as the emotion that came from contemplating one's insignificant place in the universe. And I thought that was poetic, but also surprising, because so many people seem to be so terrified of the idea that humans could be such a small part of the universe. And I can see all sorts of historical reasons that, attack the foundations of their beliefs and their personal sense and all that. But I was startled by this idea of serenity that comes from that. That was remarkable. And you didn't say it just now. You said it was more terrifying. It was like, well, do you think you might approach serenity sometime?
Well, more terrifying for me, for this little science journalist, on this, yeah. So I'm not Jim Casting, but I would get those inklings sometimes. What I would do is when I would start feeling depressed, and I was writing the book in the fall, I'd be watching the leaves change as they are right now, actually out my window, and just the change of the seasons, the change of the weather. I would be watching them out my window and feeling kind of depressed about how it's all going to go away at some point. The sun will turn into a red giant and consume the Earth, and we will all go away. And then I'd take my dog, who you met earlier, and we'll go on a long walk and just listen to the wind through the trees and feel the sun or the rain on our face. You'd have to kind of, I get that sense of serenity, that sense that, like, sure, maybe it will all go away, but that makes right now maybe all the more precious. And sure, we can't really comprehend our true place in this vast expanse of time, but we do know that, again, 4.5 billion years of planetary evolution have brought us to this moment, and it does seem to be kind of, almost a teleological thing where it is this upward movement of complexity and advancement. One thing about casting that I'll just say before we move on, I could just talk to you guys for a long time, so I'm really sorry if I'm just blabbering so much.
No, it's great.
Yeah, so casting, I think one part of his serenity comes from his optimism. I feel like in the very long view, he's actually quite the optimist, quite the techno-optimist. He believes that, yes, we're doing terrible things to biodiversity. We're in the midst of perhaps a mass extinction of our own making. Yes, climate change is real and it's terrifying. But when you look at these longer timescales, you know, a lot of that stuff kind of fades into the background. It's just a little blip. And of course, the Earth will be fine. The question is whether or not we'll be fine on the Earth. And he's a techno-optimist. He does believe that that we can kind of engineer and problem solve our way out of a lot of these quandaries we find ourselves in. And one encapsulation of that is something he said where he was talking about how we, maybe uniquely out of all the life that has ever existed on Earth, you know, we do have this choice where we can kind of maybe perhaps choose to extend the life of the biosphere in various ways, whether that's somehow moving the Earth out in its orbit or blocking it from a warmer sun or simply just traveling to another star system or other planets. And he encapsulated it by saying, you know, we could be more powerful than the cyanobacteria, the creatures that, you know, 2.4 or 2.3 billion years ago seemed to have devised oxygenic photosynthesis and filled our atmosphere with oxygen so that we can exist now. He said, you know, we could be more powerful than these other world-changing organisms. And I think he has hope.
But the cyanobacteria, poor things, it was good for us, but they came that close to killing themselves off by doing what came naturally.
I mean, just as we may be, right? So we're on the knife edge.
But if I'm beginning to see the Serenity, and thank you for, you know, suggesting that idea, because if it's awe and wonder you want, the universe has more than you can ever hope to use up. Certainly, there's just so much, and it seems endless.
Yeah, yeah.
So I want to ask a sort of technical writer publishing type question. I actually went to a talk last night from eminent comparative evolutionary biologist, and he works at the Field Museum, and his book is called How We Do It. Right.
Oh,
now,
yeah.
if you listen to this man would never say, these words would just never come from his mouth. I mean, it takes 10 minutes of listening to him going. And he said, yeah, the publisher sort of imposed that title. How about your title? Is this something you sit there, you said, this sounds like a great title, or did you, like, you know, cross off things on a paper, or did your publicist just say, oh, yeah, you're way off, we're going to sell a book with this title?
What happened is that I was coming up with potential titles for to bounce around with my agent Peter Talek, who's great, and I came up with, I think, like maybe 5, maybe 4, and this is one of them, 5 Billion Years of Solitude. The one that I really liked, actually, even more personally, when I sent it to him, was one called Terra Incognita, because, or was it Terra Cognita? I can't remember. Anyway, the notion was, you know, like, it was all these planets like Earth that we don't really know about, and la la la. And he was like, he's British, so he's like, no, Lee, that won't do at all. I'm sorry, that's Latin, it won't do. So he immediately latched on to the 5 Billion Years of Solitude title. And just to make it clear, the title comes from 2 things. One, the estimated potential total life or extent of life on Earth. You know, it started 4.5 billion years ago, more or less shortly after the planet formed. It could extend, you know, maybe some 500 million years on the lower end into the future. So you get this nice round number, 5 billion years. And then the solitude part comes from the fact that maybe we're never going to find anybody. Maybe we're never going to find anything out there. Maybe we are alone, or practically alone for all intents and purposes, and what that would mean for how kind of we view ourselves and our place in the universe. That's where the title comes from. But he liked that one, and of course, when he saw it, he was immediately like, so you must love, you know, Gabriel Garcia Marquez, right?
Marquez, yeah. I was going to say, I couldn't help the minute I saw the title, I thought of him.
It has nothing to do. Has nothing to do with that book. It's a total coincidence. I did not think about it when I was coming up with the title.
So did you go read that book?
I have read the book. I enjoy it a lot. I love magical realism, but it didn't actually have anything to do with it. I came up with it on my own, but I have now learned that someone else beat me to it. There's a great author named Kim Stanley Robinson who writes really hard science fiction, and he wrote this trilogy called the Mars Trilogy, and it's Red Mars, Green Mars, and Blue Mars, talking about how humanity will gradually colonize and then terraform the planet. And in Blue Mars, that phrase actually pops up. 5 billion years of solitude pops up there. So thank you, Kim. I will give you credit for that. Yeah, Marquez actually was not the impetus, but that's how it happened.
I took it to mean, by the way, that we have had our 5 billion years of solitude and that it's about to end.
It could be that too. It could be that, but the question is, we don't know. And to summarize what the book I think is really about. I mean, obviously we've talked about what it's about, but in a nutshell, it's just about how, and why I wrote it was because right now, all of us, everyone living on Earth, is kind of poised at this threshold, this unique moment in the history of all life on Earth, as far as we can tell, where at last, we may finally be, discovering our real cosmic context, whether or not we are, for all intents and purposes, alone. Because for me, there's no question that, of course, life is out there someplace, intelligence is out there someplace else. The question is how far away it is. And if it's really far away, if it's on the other side of the galaxy, or if we're the only ones in the Milky Way, if it's in some other galaxy far, far away, then we really are pretty much alone. And that's something to grapple with. So, yeah.
Another very quick publishing question, since Joanne got it, that I noticed is that at some point when you're talking about Frank Drake's Green Bank Conference, this is 1961, and the very interesting genesis of the Drake equation, you write it down. And my question is, 20 years ago, the advice was always never put equations in, you'll lose the audience. And so the question was, did you get any flack from your editors saying, now Lee, no equations, everybody knows that?
I didn't actually, thankfully. My wonderful editor, Emily Angel at Penguin, was remarkable. She didn't have any problem with that equation. And that is, to be fair, the only equation in the book, the only one. So there aren't any other ones, at least not any that are written out like that. So I think I definitely, for me, the hair stood up on the back of my neck when I typed it out, and I'm reading through the draft, and then I stop, and you have to see this kind of arm's length list of variables and numbers. And I'll tell you what, it was really, really painful. I narrated the audiobook version of the book, and it was really painful to say, all those times, and N sub E and F sub P and all that stuff, and putting it all together was definitely a mouthful. So I don't know if it's a good idea, if it's advisable to always open up with an equation, but it seems to have worked this time. So
it works for me.
Well, and it is, it's a famous equation that you don't say Drake without equation almost. And this is a topic that I actually brought up with Phil Plait when he wrote his book Death from the Skies, and there was not a single equation in there. In simple equations could have done really well, but just this idea I wonder what I guess publishers nixed this, but that you could have an addendum, or you have a separate workbook, that allows people who like equations to get to it, or just, in the back of the book, something that explains it. But, like I said, that's papers that cost money, so, maybe they figure that's not going to be the big selling point of a book.
Right. Even though, it depends. There is, I think, quite an audience for that kind of thing. There's a book I have on my shelf. I think it's a little bit out of view.
Do you have the Theoretical Minimum?
I do. I was going to say the Theoretical Minimum.
Yeah, that's a great book. Somehow I got 2 of them, and my daughter, who's a physics major at U of I, she just grabbed it, so there are people who like it.
Right, there is a market, a mass market for books, science books with equations that are still, popular. So I do think it's something that maybe is shifting a little bit. The rise of the internet and how you can kind of educate yourself and, look up ththings that you're curious about if you're motivated and proactive, I think makes those sorts of books more feasible to do, I think.
Yeah.
So we are approaching the end, and we do like talking, but I do want to ask, and this is always a hard one for publisher or writers to answer because they don't always know, but what's next? Is it always going to be exoplanets? Is it always going to be cosmology, astronomy, or are you going to try and branch out into something else?
Oh, man. I'm really actually trying to answer that question for myself right now. I would love to do another book about exoplanets and about the search for life, but I think that it's going to have to be a while. I'm going to have to let things cool off, and I'm going to have to let I'm really going to have to let the field kind of not catch up to me, but just catch up with itself. Where there's all these ideas and all these proposals, and we're still kind of in the early days. These are still the very early days, and so I like to think that maybe 5 years down the road, 10 years down the road, we'll actually have so much more to talk about that it'll then be time to revisit the topic. And I don't want to get pigeonholed. I've kind of been pigeonholing myself. If you look at my Twitter feed, it's just all exoplanets and the search for life all the time. But I'm thinking a lot about maybe I just can't get over the fact that that climate change, global climate change, is really, I do think it's kind of the existential threat of our time. I mean, more so than, things like terrorism and weapons of mass destruction. I really feel like it's the story. It's so huge and it's so large and rich and multifaceted, and it's so important. It's so incredibly important. So and tragic. You get the more you know about it, the more you really have to just lament and mourn for what's happening. And there's something very powerful and sad about that I'd like to try to capture. But so many other people have done that. So I don't know if I'd really have anything new to say. But so we're thinking about it. It's in process.
Two things that we like to draw to a close with and become traditional. One, if you have any books that you've been reading lately that have interested you that you'd like to tell us about, do that, and then you get to let us know if there's a question we forgot to ask that you particularly wanted to answer today.
Okay.
Thank you for asking that, Jeff. While I ran off to turn off an alarm that was trying to go.
Ah, good.
Well, I'll do a few. I actually want to hold on. Where did I put it? Oh, you know what? I'm propping my computer up with this book right now. But no, I really haven't been reading it, so it's.
Well, that shows how much you rely on it.
It's so I keep it close at hand. Yes. I haven't been enjoying this book very much by my friend Katie Harmon Courage. Yeah, and it's a very good book. It's her story of kind of going around, traveling around different parts of the world, discovering all these fascinating facts about these mysterious creatures. I find by the way, it's not octopi, it's octopuses.
Octopody.
So or octopody, but it's octopuses apparently. That's what she says. So
in English it is. Yeah.
I've been very fascinated with this just because octopuses are very interesting to me. I think they're kind of like the closest we can get to like legit aliens on Earth.
Yeah.
So very cool book. Let me get two more. I'll be right back. 1 second.
Great. Hey, wonderful. Hey, while he's run off, I'm actually doing a hangout with Scientific American on Monday about unmanned space travel with the director of planetary sciences at NASA.
Well, that's very exciting.
Day off, I'll be interviewing him. So we'll be talking about unmanned space travel, so you guys can join me on your Columbus Day if you're not celebrating.
Are you talking about Commander Hadfield?
Commander Hadfield, everybody, good news. We have Commander Hadfield November 14th with Scientific American. Jeff and I will interview him because he will be talking about his book, An Astronaut's Guide to Life. And there's also a picture book out called Earth that we will talk about with him. But I was talking about Monday, I'll be talking to the director of planetary sciences at NASA about unmanned space travel. I've been trying, so because the MAVEN launch is coming up and they got an emergency exemption for the funding issue because if they don't get this orbiter off now, it's like 8 years.
Yeah,
the window's gone for 8 years. And but the importance of it, besides looking at the atmosphere of Mars and trying to figure out where did it go, is that it's important in relaying some signals from the vehicles that are already on the planet. So that that was part of what allowed this exemption. So I'll be going down to see the launch in November.
Yeah.
So hopefully there'll be someone able to let me in on KSC, right? Because if everybody's off work, then that might be a little. I'll stand on a beach somewhere to watch it because apparently that rocket's going off. So anyway, let's hear more about books.
So I totally got to tune into that though. So the other two books I want to highlight are actually kind of perennial classics for me. One I'm only experiencing the first time. The other one I revisit repeatedly, and I basically reread it every year, the same way some people do with like Lord of the Rings or whatever. So this one is by Stanislaw Lem. He's a Polish author, deceased unfortunately. This is called I believe it's Latin, Summa Technologia. Yeah. And it's just been translated into English for the first time. I think he wrote it in the early or mid-1960s, and it's amazing. You can read it, and it reads as fresh as a baby's bottom today. It's a great book, and it's all about the question of life and intelligence and technology in the universe and kind of where it comes from and where it might go. And it's just amazingly prescient and a beautiful book. I think that if he hadn't been a science fiction writer, he probably would have gotten a Nobel Prize before he died. So the other book is also by Stanislaw Lem, and it's called Fiasco. And this is the novel he wrote, I believe, in 1986 in Polish. It was translated into English in 1989 by Michael Kandel. And apparently he wrote it just for money, just on spec, but it contains, it is a hall of mirrors in which you can see whatever you want to see. It contains multitudes. It's a beautiful book about what may be the futility of trying to make contact with alien intelligences, and it also gets into this question of kind of, how do intelligent technological civilizations evolve and change over time in the universe? What are the various end states? Are there certain stable points that they reach where they kind of achieve stasis and they don't do anything? Or what does the future hold, not only for them but potentially for us? And it's just it's a gorgeous, fantastic meditation on these deep questions. I cannot recommend it highly enough to anyone interested in these topics. So
great ideas.
And the final, I guess, in terms of a question that you didn't ask, I would say maybe the question would be like, am I hopeful about finding these other planets and finding signs of life on them?
Do you feel optimistic, Lee? Tell us.
I don't. I feel pretty pessimistic, and I really hope I'm wrong. And I will say that maybe part of me flaunting my pessimism is as a prod to say, prove me wrong. Prove me wrong that I mean, because clearly it's all about me. But
yeah,
I guess a lot of people see technology, or they see like our exploration, our efforts to reach out into space and learn more about our place in the universe as this this kind of unstoppable upward trajectory, this quest that we're on, and we will not be stopped. And that's just not clear to me at all that that's the case. You can look through history, recent history. You can look through right now what's going on with our government. If you're a U.S. citizen. And the shutdown, and you can just see that so often, reality and what's that?
It can be stopped.
It can be stopped very easily by very mundane, silly things. And I look at what seems to be in store for us in the future, whether you're talking about kind of longer term things like climate change, or the I guess at some point the sun boiling the ocean, but more like climate change caused by us, mass extinctions, it seems more and more difficult to organize ourselves to do great things, at least in this country, and that really bothers me a lot. So I see that, and I think about things in the past that haven't worked out as people thought they would, whether it's us landing on Mars, or going back to the moon, or making a fusion reactor, or whatever it is, and I think that maybe we have all this momentum behind this quest for life, behind the notion of building these big space telescopes to finally answer these timeless questions. It's within our grasp. And I think that we really shouldn't squander that momentum. I really feel like, maybe this is it. Maybe we really don't have, an infinite number of chances to get this right. So that's something that I would like to close with, that I wrote this book because I think it's important now. For us to spend kind of our day in the sun doing this. I feel like it could really change our perspective on things in ways that could be useful for us here on our own planet. Maybe we could take better care of ourselves and our own planet by having a greater appreciation of what's really out there, whether or not we are practically alone.
That's a good Carl Sagan sentiment, isn't it? So just for everybody out there, I'd like to recommend 5 Billion Years of Solitude, because I really did enjoy it. And as if you haven't been here for the whole conversation, there were characters in there that really stood out to me, and I thought Lee did a fantastic job. And it's an exploration of a topic that's hot right now, isn't it? And and Lee, thank you for being here and taking time to talk with us.
Joanne, Jeff, it's really been my pleasure. I've found more, I've learned more about you in this process, and you're both super interesting. I'd love to, for my next book, if there is another one, I'd love to talk to you again about it, and I hope we can stay in touch. It's been a blast. Thank you so much.
We'll find a reason to continue the conversation, I'm pretty sure.
For sure.
Absolutely.
Thanks very much, Lee.
So I'm going to end the broadcast. Thank you, everybody, for tuning in, and we'll see you on our next episode.
Bye.